Hi everyone, I am Kalaimani AI, Assistant Professor of CSE Department from K.S.Rangasamy College of Technology. In this video, we are going to see about the operating system services, system calls and system programs. Operating system services. Basically, we are having 8 operating system services. Number 1, program execution, I/O operations, file systems, communications and error detections. These are the 6 basic operating system services. Additionally, we are having 3 operating system services: resource allocation, accounting, protection and security. In depth, we are going to see about these 8 operating systems. Program execution. When we execute a program, the system must be able to load a program into the memory and to run that program end execution either normally or abnormally. When we are executing a program and also when we are completing the execution of a program, whether it is normal or abnormal, the actions involved are given, the services given by the program execution service. And the next one is I/O operations. When the input output operations or a device is involved, the services are given by the I/O operations. And the next one is file system manipulation. When we go for file accessing, when we are creating a file or accessing a file, delete them or search some content of the file, those services are given by the file system manipulations. And the next one is communication. When the process exchange information or when we go for a cooperating process, the process executed simultaneously, we are having the cooperating process concepts. In those concepts, when we exchange, when we are in need of exchanging the information between one process to the another process, those communications are established through the communication service. And the next one is error detection. Usually the user have to they should know about the errors that may occur while executing a program. OS needs to be constantly aware of the possible errors may occur in CPU and memory hardware in I/O devices when we go for the user program. For each type of error, the OS should take the appropriate action to ensure correct and consistent computing. These are the services included in error detection. Additionally, we are having 3 more services: resource allocation, accounting, protection and security. When we go for the resource allocation, each process can have more number of resources. When a group of process is executing, when we go for the multi-programming, group of process are executing, they have to share the resource. Based on the requirement of a process, the resources have to be allocated by the service resource allocation. Accounting. The accounting to keep track of which user use how much and what kind of computer resource. Those kind of data have to be keep track and also it should be maintained with different process. These services are provided by the accounting service. And the next one is protection and security. When we go for the protection, it involves ensuring that all access to system resource is controlled. All the system resources access have to be controlled by which process can access which resource. That is given by the protection services. When we go for the security, the system from outsiders require user authentication. By the user authentication, mainly we are enabling the security that is mainly provided by the security services. We are having 8 operating system services: program execution, I/O system, file manipulations, resource allocation, accounting, protection and security. These are the 8 services provided by the operating system. And the next one, system calls. What is, first of all, we have to see what is system calls. The system call is an interface between the program and the operating system, the user program and the operating system. The interface, we call it as a system calls. 3 general methods are used to pass parameters between the running program and the operating system. When the program is in execution, we call it as a process. The process, how it interact with the operating system through some parameter passing. We are having 3 general methods for those parameters passing. The first method is pass parameters in registers. We are saving the value in registers, then the registers are passed as parameters. That's the first method for passing parameters by the process to the operating system. And the second method is we are storing the parameters in the table in a memory. Then the table address is passed to the operating system as parameters. This is the second method for the parameter passing. And while we go for the third methods, we are pushing the parameters onto the stack and it is sent to the operating system. It pops off the data from the stack. This is the third method of access methods. Operating system, where the process interacts with the operating system by having three methods. First one, pass by registers. Second one, store the parameters in a table and pass the address of the table. And the third one, we are pushing the parameters onto the stack and the operating system will pop off the stack values as a parameters. These are the three methods for passing the parameters to the operating system. And the next one, this is a block diagram for passing parameter as a table. We are loading the address of X and the system call 13 is encountered. The registers, those register X is passed as parameters. The code for the system call 13 is processed. After processing it, it will return to the user program. This is the concept of passing parameter as a table. System calls, it is a programming interface provided by the operating system. The three most common using system calls are, when we go for the Windows 32 API is used for the system calls for Windows. The API is nothing but application program interface, mostly accessed by the programs via the high level application program interface rather than using direct system call. Each and every operating system is having its own API. That API generates the system calls and it provides to the operating system. The operating system provides services based on the operating system calls provided by the API. When we go for POSIX based like Linux or Mac OS, it generates POSIX API. When we go for the Java virtual machine, it uses Java API. This is an example for system call for transferring content of one file to the another file. These are the number of sequence calls, system calls we are enabling for transferring one file content to the another file. First of all, it acquires the input file name which is having the content, the source file name, write prompt to the screen. So, it gets the content of that file name, accept the input, acquire output file name. In which destination file we are going to replace the content, that file name it acquire, write prompt to the screen and it accepts the input as a destination file name. Open that input file which we get from the starting. If file does not exist, the process automatically abort. So, the abort system call arises. When we create the output file, if we are getting the destination file name, those file name has to be created as an output file. If file exists, abort. If it already exists, we have to stop the process. Otherwise, we are creating the process, the loop starts, read from input file. We are reading content of input file, the first line of input file, and it write it to the output file until read fails. When the read fails, when the pointer reaches the end of input of source file, then the read operation gets failed. Until then, it repeats its operation, it reads the second line, it reads and writes the second line to the destination, it reads the next line until end of file. When the read fails, then it means that the source files doesn't have any content. Then it closes the output file, write completion message to the screen and terminate normally. These are the sequence of system calls for copy the content of one file to the another file. Next one is how we are implementing the system call. Typically a number associated with each system call, each and every system call is having a number. A system call interface maintain a table indexed according to this number. Each and the system calls are arranged in a table. The system call interface invokes intended system call in operating system kernel and returns status of the system call and any return values. The system calls interface invokes, there is an interface for system call to the operating system. The interface invokes that intended system call to the operating system kernel, the kernel of the operating system, and returns the status of the system call. What it happens like that, it returns the status. If it wants to return any written values, then that value also returned by the interface. The caller need not know about how the system call is implemented. The operating system designer have to be known. So only we are studying in this. This is an implementation of a system call. When the user application is given, the API generates a system call open and it given to the system call interface. The system call interface intent, it executes the opening of a particular file. It will opens and it returns to the interface. That interface intent, it will be given the output of that file, opening of that file. That means it returns the file content to the user application. In this way it is executing the system calls. Mainly the system call is generated by the API in the user mode. When it go for the system call executed by the operating system, it is in kernel mode. After it returns to the interface, it switches from kernel mode to the user mode and it returns that file operations to the application. We are having 5 types of system calls. The first one is process control. The process control intent, it explains how we are controlling the process, creating process, terminating process, ending the process or aborting the process, load the process, execute the process. Like those system calls are included in process control. And the next one is file management. It create file, delete file, open file, close file, read file, write file. Like those system calls are included in file management. And the next one is device management. These system calls are used to operate on devices, input or output devices. We are request for the devices, we are releasing the devices, we are read from devices or write to devices, get device attributes, set device attributes. Like those system calls are included in this information maintenance. The basic system information maintenance are maintained in information maintenance system called get time or set time or date, set time or date, get system data, set system data, get or set process, files or device attributes. These are the system calls included in information management. And next we are going for the communication system calls. Here we are sending the messages, receiving the messages, create communication connection, delete communication connection, status, transfer status information, attach with the devices, detach with the devices. These are the system calls included when we go for the communication system calls. Mainly we are having 5 types of system calls: process control, device management, information maintenance, communication management and process control. These are the 5 system calls we are having. And the next one is system programs. Generally the program is nothing but sequence of instructions. Here when we go for the system programs, we are having sequence of system calls. Those system calls are embedded with a single name called system programs. Usually we are having system call interface. It is maintained as a table. We all know that each system call is having a separate number that is maintained in the table. The system program, when we are going for the system program, it provides a convenient environment for the program development and execution. This can be divided into 7 types. The first one is file manipulation, second one status information, next file modification, programming language support, program loading and execution, communication and application programs. These are the 7 parts of the 7 types of system programs we can embed by using the system calls. Most users' view of the operating system is defined by the system program, not the actual system calls. They are not giving the system calls, instead they are providing the system programs to execute in these fields. Thank you.